Hello there, Bruce here, and I'm opening up Unity for the first time in a couple of years. I decided to hit record as I was stepping through an old tutorial project and realized, or at least had the thought, maybe if I record myself stepping through this might help other people similarly. Because if you ever try to pick up a coding project, a Unity project, for the first time in a long time, it's disorienting, and sometimes that is enough to paralyze some people and cause them to just exit out and quit. Like, where do I even start? I got, oh yeah, different views here and the hierarchy. There's objects and there's stuff on it. Oh my goodness, it's overwhelming. Um, for some of you that might not be the case, but for some it is, and it's okay as long as you find a way to get through it. Because if you want to do Unity, if you want to do whatever you want to do, and it's been a while, maybe life got in the way, you doubted yourself, things got too hard, and you're like, alright, shaking it off, coming back into it, oh no, everything is so big. I'm gonna record myself doing that exact thing. Stepping through, okay, where did I begin? And this is helpful for some of us. Our learning style is by example. I could go and do another couple tutorials, but I decided to try to check this out. Pulling from memory. Now, I did used to work, not even work. I used to play with Unity just a little bit here and there every few years for the last decade. I never really committed to actually building anything. That's a whole story for another time, if you're interested. Weird life story, but it's not about me, it's about this. And so, I'm gonna step through. I'm gonna record this. I'm gonna upload it. And whether I later think, this is stupid and trash and delete it, or it just simply gets no views, then so be it. If at least one of you gains something positive from this, please leave me a comment. That isn't for engagement, for money, or whatever. It's literally communication. So I know someone out there has found this helpful, because I want to help. I am helping myself by stepping through this, speaking aloud, okay, this is doing this is doing this. But if I can help someone else at the same time, incredible. So, let's begin. Unity. And, wow, if someone's even has no idea what Unity is and this is their first foray, hopefully I do a good job at explaining. I'm not going to tailor it too much to someone who is completely brand new, but I'm going to step through this. I open this tutorial project boost, and it's from gamedev.tv. Great, they've got great tutorials, not only Unity, but Unreal and Blender and other programs. Check them out, for sure. I have no affiliate code. Maybe later I drop one in. I don't know. Point is, here we are. Now I remember I arranged my windows to be like this. Game is over here so that my scene, what I actually manipulate my objects, move the camera and stuff, that's right here, right next to the hierarchy. And the hierarchy is right next to the inspector, so all the properties are immediately here. Whereas the default hierarchy is on the left, and the inspector's on the right. Moving your eyes back and forth, I put it there. And at the bottom is our folders. We have our assets folder in which everything that we've created lives. And then there's packages from which there's the default blocks of code, the packages that come with, as well as anything we choose to install. Now I don't recall installing anything. This all looks like Unity stuff. Visual Studio, VS Code. I know JetBrains is still more Visual Code stuff. So we have our assets. Scripts folder, where our scripts live. Scenes. Scenes is where, this is a scene right here. A level, if you so choose. And there's over and under. It's not level 1 and level 0. Well, considering it looks like I spent way less time on this one, I'm going to guess this is level 1. And this is level 2. Now, I do happen to remember that there is such a thing as build order. So file, build settings. This is where you not only choose where to target the deployment of your game to what platform, but even just when you're running locally, this is very important. Every single project, very relevant, is the scenes in build, and it does it by order. There are numbers. Now, of course, you can write scripts to jump to any scene you wish, But by default, when Unity loads, it's gonna load 0. It's gonna load the first one. So under, and then over. Cool. So this is under. Alright, and I've got my... yeah, so middle mouse button, hand. So I'm clicking into the button and moving. Left click is just a selection tool. Right click, pivot around from where the camera is. I don't know quite how to move. Okay, here's arrow keys. Shift is how you speed it up, I guess. And then also I remember there's focus. So if I focus on my rocket and hit F, it focuses in on it. And then there's a camera. So how it actually, whatever we see here on the left side of the screen, there is a camera. And it's positioned thusly. If we look at the properties, perspective. I believe this is where it's... There's nothing where it's targeting. There's nothing where it's looking at anything. It's just a basic camera. It's not following. There is such a thing as Cinemachine. It's a camera package that comes with all of these tools to stay focused on a target as it moves across the scene, or to set up animations, transitions, all sorts of stuff. Cinemachine. But this is a default camera. And so, we have our scene under. Let's see what else we have. We have prefabs. Prefabs are classes of objects, basically. You can instantiate each one just by dragging it on. Like there's another launch pad. And it comes with a bunch of properties. Yeah, so... Whew. It's okay. Breathe. It's a lot of information. We're going to breathe. Before I get into the properties, I just want to see what other folders I have. Materials, which is just responsible for the coloring. The coloring, just like that, I dropped a material on. Such that if multiple scenes in the object have a color, then later we decide we want the color to be a different shade. We don't have to go and find each object and change the color, we just change the material that's attached to all the objects, so it changes all in one place. Here's some other materials thing. Okay, I'll ignore it. Low poly kits. It looks like I imported some objects. So there we go. And then there's audio. There's death explosion, main engine thrust, and success. Okay, so success. Probably a sound effect that plays when I hit the launch pad. Death explosion, probably if I run into an object or hit the ground. And main engine thrust, so the sound of when we're thrusting. So here, I'll just hit play. I'm on the first level. Just gonna hit play, and then I'll dive into the objects and how it all works. So, space, isn't it? Oh wait, game. I have to click on the game. Okay, it is space. Woo! Where'd it go? Oh, that's loud too. So we can change the sound volume. We can change how it thrusts. I know that. So every object, if it's coded right with public fields or what's called serialized fields. Serialized just meaning it gets saved. Basically, it means it gets saved. It's a public field that shows up in the inspector. Here, well, I'll show. Rocket. Aha! So I completed it. I wasn't really paying attention there. But if I click on the rocket... Yep, we can... These are serializable fields. So I bet, if I remember correctly, this movement script has public fields that we can change here in the inspector. And then private fields we don't see here, because they're relevant just to the script itself. Doesn't need to be changed by the game designer if you're working in a team. Else it's yourself. Here, just to make it easy. And I know, also I remember, when the game is playing, if you make adjustments here and then cancel, it does go back to the default. But then if you change it here when the game's not playing, then it's like save for real. So, rocket. I'm gonna start first object, rocket. That's our player. I'm gonna see what's underneath. Particles. Okay, so particles are attached to the rocket. Here's a mesh cube. Okay, so it looks like. What happens if I hide this? So there is like a cube mesh filter, but it's not. It's just an empty mesh, and so what we do is we add a new game object that's a mesh and a mesh renderer. See, there's no mesh renderer. It's just here. And it's got different materials. This, and it doesn't look it doesn't look toggleable. I'm not sure what's up with this. Oh, wait, look at this. I bet this is an image. I bet this came from this low poly kits. Yep, right here. And this is already pre-configured to have different materials for its different parts. We don't see its different parts listed here because it is like a packaged game object, a prefab. And I don't need a change, so I'm not going to go and try to figure that out. There are two lights. So in the inspector, what we see here, most everything, I believe, that is placed in the scene view is a game object. And it always has a transform. It always has a position, a rotation, a scale, optionally, even if it's not shown visibly. But then you add stuff to it to make it a thing. You add a light component to make it a light. You add a rigid body to make it a rigid body, which means it has physics interaction. Interacts with the Unity physics engine by being called a rigid body. And it has a mass, drag. Does it use gravity? Do you freeze its position? Yeah, so when you move it around, sometimes weird things can happen. Even if you just say, we're only ever moving left or right on this axis. If you bump into something, it might apply force to like the Y and Z randomly. So you do, on constraints, lock it in. In this case, Z position, we don't want it to go front and back. It's always left and right. We're simulating 2D, but it's 3D. And then rotation, we only want it to move this way. And how do we check that? So that's how. What we do is we click this object, and there are tools right here. There's the view tool, the move tool, and you can see 3 arrows where you can move it on that axis, and that axis. And if you don't know which one it is, if you don't remember the colors, you can just look over here at the transform. So if I move on the red, X changes, blue, Z changes, and Y, green. Now, despite that, even though X is front and back, when we come to rotation, I'm not exactly sure why, because you'd expect what looks like X rotation to be front and back. Or you would expect to be side to side, like Z is. Okay, so it's Z. So we're moving Z. So we go back to this. We're allowing Z rotation, but freezing the others. Cool. And what else is a rocket? A rocket has a box collider, so it actually collides with objects. It collides into this. It collides into the ground, if they all have colliders. I believe ground has a collider. Launch pad, landing pad has colliders. Ground, very simple. The directional light, I believe this is default Unity. It's dropped in when you create a new scene. Don't think I changed it at all. Maybe I did, this 50-30, whatever. So, and then there's obstacle, and then we'll really dig into rocket. So obstacle, also just a box collider. There's no special scripts. If I go to my assets folder, the root, and go to scripts, I can see I have 3 scripts. I have an oscillator, which doesn't sound like it would be on my player class. Maybe it's for an obstacle to oscillate. Movement The only thing we're, yeah, movement is usually movement script. Yep, here's the speed thrust, the rotation, the clips, and the particles that we saw on here. So there we go. And collision handler. So there's no, I bet obstacle. We'll put an oscillator on it. Oh, and then we can change the movement factor, the period, back and forth, or what have you, and then the movement vector. Where is it actually moving to? So let's play with this. What does this do? Wasn't what I was planning on doing. Okay. So yeah, it's going from 0 to 5. Okay, so it starts at 0 because this is how it goes. From the initial position to the movement vector and back. And we'll figure out what the period does in the script. Actually, let's look at it now. Float period 2. So has this starting position. The starting position is the transform position. So every script, most scripts. Alright, there's a number of ways I could go about talking about this. Let's assume pretty noob, but not entirely noob. This is C#, and this class that we've declared oscillator, this colon to another class name means it inherits. It is a child of. It's inheriting certain properties and methods that exist on it that we can override, implement. We're implementing this. And basically what this means is how Unity compiles the game, how Unity brings all of this together, is there's a lot of code under the hood. And some of this code finds mono behaviors and executes certain methods. In particular, two. There are many. In particular, two. The start and the update that we see here. So when an object is loaded into the scene, the game begins, the start method is automatically called. And that's because it's a mono behavior. And start just gets called on all of them. And in the start method, we're setting this starting position variable to the transform.position. And hey, I will open this up in Visual Code so that we can see it with colors and highlights. We have the starting position, and in the start method, call before the first frame update, we're getting the transform.position. And this transform, where is this coming from? Well, it's likely in the mono behavior. And we know this. So, documentation. This is another thing that often trips up developers. We have to get used to looking at other people's docs and understanding it. And I think really the more you look at them, the more it clicks. I remember the first several years, it always seemed so daunting. One day it just clicked and I went, oh, I just get it. This is how I find it. This is what I do. So, in Unity, I believe there is a scripting reference. Let's open it here. So, wow, this is a lot. There's Unity Engine and Editor and Unity. That's a lot. But what were we looking for? Mono behavior. So we're going to search for that. All right. Mono behavior. Cool. So that actually wasn't very helpful. The transform. Yeah, so what I was hoping to see is mono behavior. Here we go. Transform. This is where we're getting it. So let's go back to the code. This whole transform. Yeah, we're gonna pop on it. I'm splashing. Hey, I'm 98. It's magic. If you know, you know. Actually, I'm about to log out. This transform must be declared in here because we don't see it anywhere else. It's declared. So what I did is pulled up the documentation, looked for mono behavior. It is the base class from which every Unity script derives. When you use C#, you must explicitly derive from mono behavior. So this is bar none, you must. For every Unity script. Now, the functions, so there's a checkbox for enabling or disabling mono behavior in the Unity editor. It disables functions when unticked. If none of these functions are present in the script, the Unity editor does not display the checkbox. Okay, so what does that mean? We go here, we go to our obstacle. What's this? This is the mono behavior, this is, right? Oh no, I hope I don't give you... I mean, I'm not seeing it. Point out in the comments if I'm not seeing it. I mean, there's unchecking the script so it's no longer running. Then there's just not enabling the game object. Overrides, this deals with when you have a prefab. You make changes to an instance of the prefab and you wish to save it to the prefab. Then you like apply all to the prefab. You can open the prefab or just select it in here. Layer, so layer deals with collisions, and you can specify what layer, what collision layer an object is on, and then you can specify certain objects can only collide with other objects that are on this collision layer, or these collision layers. You can have multiple. And then the tags also are used for detecting when you've run into something, or like let's say you have an object on the ground to pick up for extra fuel. Well, when you collide with that, you don't want it to collide and end your game. You want it to collide, detect that it's a fuel object, and add fuel to your fuel capacity. So you use tags for that. And again, layer is for collisions. And so, just real quick, we were looking at transform. So there's all these there's these public methods to call. There's the static method, print. It logs to the Unity console. Different messages. So what this means is when something is... You can listen for when a message is sent. When something happens in the game, it sends... Usually it sends out a call. It says, awake. I'll do a better job explaining that if you're curious. You could likely find the answer elsewhere. Sorry I didn't explain it that well. Moving on. Our public methods, you can call on it. Static methods and operators. But this is what I was really looking for. Transform. We have inherited members. This is what's inherited. This is just on the mono behavior. These are inherited. So this transform here, the transform attached to this game object, we called here, that is actually here. So these are called components, and we have this transform component. Sometimes when you add something, especially like a new one, like an oscillator, something we've defined, you're not going to be able to just type oscillator dot whatever. Dot. It doesn't work that way. It works for transform because it's already defined as a property on mono behavior. That's how we're able to just hit transform. You could also just do tag dot or game object dot. Look, game object dot. I'm not getting a list of... So that's something we'll have to set up. Set up Unity shortcuts, some sort of Unity extension in your code editor. It should give you a list of methods that are attached to that. But this transform. So again, when the game loads and this object starts, we're saving the starting position, transform.position. So what it already is, which is this, and it's 3 values. It's X, Y, and Z, which in Unity is actually encapsulated in a class called vector3. Now there's vector2 where it's just X and Y, but then vector3 has the X, Y, and Z. And we know that. I'll just to build familiarity with APIs, clicked into it. So transform, there are a number of methods you can call on it. You can translate it, you can rotate it, you can look at it. And so we used, well, we're just looking for a position. The world space. And the position is giving us an example. And you see transform.position plus. So if you want to add to it, you need to, well, add it by a like kind data type, which is vector3. So up to the first comma, here's the x. So let's say it's 0, 0, 0. Well, we're adding for the x, horizontal input times movement speed times time dot delta time. And then the y, where we are plussing that. And for z, 0. Cool. So the update, once per frame. This is always going. Every frame, it's doing it. So period less than or equal to a very small number. It's basically 0. Mathf.epsilon is a sound way of doing 0 without saying 0. If you're confused by that, look that up. So it's a little bit of math to determine the sine wave in which so it starts and ends. A little bit of math here. Of course, it's been a while, so I'm like, oh yeah, what is this? Ah, yes, tau pi times 2. Yep, this. I'd have to refresh myself. And in fact, you can use ChatGPT. Drop this in and ask it. Here, we'll do that. We're in the age of AI. This is going to be so commonplace. This is going to be very commonplace with tutorials, is also helping you to understand how to use AI. So let's say you find some code in your project you're confused about. You go, please explain what this code does in a game object, in a mono behaviors update method. This is what you do. You take a bit of code and you say, please explain, what does this do? Mathf.epsilon, which is a very small number close to 0, used to avoid division by 0 errors or very small periods that could cause unexpected behavior. If period is effectively 0, the update method returns immediately and no movement is calculated. Boom. So it steps through exactly what this does. So the overall effect of this code is to make the game object oscillate smoothly along a defined direction, given by movement vector. The speed and frequency of the oscillation are controlled by the period variable. This could be used, for example, to create a floating or bobbing motion. Look at that. Wow. So that's what that does. And just a little bit more. We're going to get to the rocket. We're going to get into these scripts, and then we should be good. Hopefully I've done a good job explaining. If I have, please leave a comment, literally just to inform me, just to let me know someone is watching it and you found it valuable. If I receive such comments, I'll be encouraged, incentivized to do more of this. Who knows if this was valuable, other than you. And if it's not, awesome. Bye. No, I'm gonna keep trying to make different videos and see what happens. Alright, so audio source, I remember also is a Unity default component, wherein it takes in an audio clip type. It takes in a audio mixer group, so that's the output. So likely you have different what are called mixer groups that you can, so you have a bunch of objects emitting a certain type of sound effect, and you want to adjust the volume of all of those types of effects all at once. You route it all through a particular mixer group, like SFX, object SFX. Then you can do your effects and your volume control from there. You can just in this inspector, just straight mute it, do these other things, loop it, yada yada. But there's no audio clip. So it's not just going to play one. And in fact, if we remember, oh yes, our audio file has several different ones. And if we look down, in our scripts, we have defined and attached the thrust on the movement, and then on collision handler, the success sound effect, and the death explosion. So these scripts likely interact with the audio source component, telling the audio source component, hey, play this sound effect. Hey, play these sound effects. So all of these sound effects are going to be routed through this mixer group if it's defined. And these are what get changed all at the same time when you make changes to this. So, that's that. Box collider, that's a little green box you see around here. This is this little light green box around the object is what is used to detect collision with something else. So you see here on the launch pad, there's the green. Ground is subtle, you can see it on the outside. Obstacles, subtle, you can see it. So it's a box, and you can have different shaped colliders, capsule, sphere. You want to use the most simple one, because when you have a ton of colliders, then it gets mathematically expensive, as it's called. There's a lot more calculations going on, which could slow down especially less performant computers. And so we're arriving toward the end. We have two scenes. I'm still just in this one, then I'll take a look at the other. Just because it looks like there's some lighting fun bits there, but we'll see. So in the movement script, we'll open that up. Serialized field. Again, if you forgot what this is a public identifier. It's a property type, basically. We're saying instead of putting private or public, serialized field is public that also gets saved to the object. This lets Unity know, hey, when a value is changed and saved here, we actually want to persist that when we close out Unity and open it again. But any new object that we attach movement script to, it'll inherit these as defaults. And then individually you can override it. And you won't see the override change in the code, of course, that's code. And then there's the game object that you can manipulate that overrides the code. So the audio clip component, rigid body, audio source. So we do this in the start method. RB is this and audio source is this. It's called caching. So instead of down below in the code, every time we want to interact with a rigid body, we don't have to, it's literally a calculation to go and find the component rigid body and bring it in. Instead, we're just caching the reference. We don't have to go and find it. We know where it is already because we're saving it in this. And then same with audio source. So down below, we're likely going to see there's multiple references to audio source. And there's 1, 2, 3, multiple references to the rigid body. So in the start, we're just caching that. These don't need to be cached in the way because we're setting them here. You notice we're not setting the rigid body or audio source. They are components that sit on the game object that we could call at any point using this method, which just means is get component, but we specify the type. We're going to get the component that's of the type rigid body, or we're going to get the component that's of the type audio source. Things get a little weird when you have multiple. Is there get components? And I don't have the tool to have IntelliSense to show me the methods and the types. Not going to be for this video. Update. So every single update, we want to process the thrust and process rotation. Now we know if we're not giving input, then it's not thrusting and it's not rotating. So we're likely going to see that. In process thrust, here it is, right below. If input.getKey equals key code, or if input.key of the key space, and how you access that is using this, which is either in Unity Engine or Collections Generic. That's where this comes from. And when it comes to this, you're like, oh, but like, how did you know to use that? How do I know? This is where you just have to rebuild your familiarity with it. You will have to look up, like, okay, I want to move this. How do I move it? Let's do some Googling. Unity, get keyboard input. Like, I want to, when I hit W, move it. Okay. Input. Interface into the input system. And this goes and tells you that this is something that Unity has built, that when you're calling it in the method, when you're calling it in the code, you can see every update, it is just seeing, hey, and what this does is there a key currently pressed? Is there a space key that is currently being pressed? And we know that if we go here, get key, there's get key, returns true while the user holds down the key identified by name. There's also get key down during the frame that the user starts pressing down, or get key up during the frame that the user releases the key. Then you can do get mouse button down or up, get touch, get button, get axis. There's different things for you to take some time. Remember, breathe, take some time. If this doesn't make sense, you can use AI, ChatGPT, and others. Don't become too reliant on those, because these tools are prone to give some incorrect information. I would recommend finding an online forum, finding an online community. It could be Reddit, it could be Stack Overflow, somewhere, a YouTube community, where you can ask questions, and you'll hopefully get some response, some answers. I know the gamedev.tv platform, that community was pretty active when I was using it. It might still be. Something to check out. They'll be able to help you figure out what is all this. Wow, it's a lot. So every frame, we're checking if space is pressed. And if it is, we're going to start thrusting. So we have another method, just so that we keep code clean, because we could have all of this inside here, and then this inside here, but we've abstracted it out, so it makes it very simple. Every update, process thrust. If the key is pressed, start thrusting. If it's not, stop thrusting. So to start thrusting, it adds relative force. You can look at the documentation how this works. But it applies a force to the rigid body. This is physics. Applying the force. And there's gravity. Remember, because we're using the gravity system, there's always a force being pushed down, basically. Gravity is always pulling down. So if you're not thrusting, we can see we're not doing like a apply force downward to get back to the ground. It's automatically happening. But when we start thrusting, we're adding a force. If an audio source is not playing, then we want to play the main engine. We want to... This is the method for it. This main engine is what we have clipped in here. If we go back to the inspector, it's this. Boom, boom. That's going to open. No, it doesn't want to play. But we've attached it here. That's what's here. And when we're thrusting, we're playing it. And the reason this is it, if it's not playing, is just to prevent the audio from stacking on itself. We only want to play it when it's not playing. And even though it's very quick, it's like, I think less than a second, it'll go psh, 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 instead of psh, and just go out of control. Same with the particles. So we're doing it for both the sound source and the particles. This is how it works. And when we're not pressing the space key, we're going to stop the source and we're going to stop the particles. So after we process thrust, we're processing rotation. And understand, these updates are happening very quickly. 1/60th of a second type of thing. So very fast. So basically the thrust and the rotation are happening at the same time to our perspective. And we've defined if A is pressed, rotate left. If D is pressed, rotate right. If neither are pressed, and stop rotating. If it stop rotating, we've simply just said, just turn the particles off. Because left and right, they call this apply rotation. Applies a positive speed rotation, a negative speed rotation. So this is playing on the axis. Applying it, if we're going left, this is how it was coded. Such that the rotation this frame, which is the speed rotation, which is what we've defined here, So you see 50, but I've set it as 100. That freeze rotation so we can manually rotate. I believe this is just to help with bugs. And you see it, we freeze and we stop, and this is happening very quickly, so it's like, this is probably bug related with colliding with other objects. So we control the rotation. We don't let anything else outside of this control the rotation. We freeze the rotation and we rotate. And we rotate it by a vector 3 forward, which this is just like 0, 1, 0 or 1, 0, 0. It's whatever is forward times the magnitude of the rotation, how much we're rotating, basically how fast it rotates. And then you'll see this a lot through your code, time.delta time. This brings it down to, you could say like a realistic amount. It multiplies it by the frame duration instead of a whole second, basically. That's not the best way to explain it. It brings it down to reality. When you're dealing with physics and movement and such things, you multiply it by time.delta time, and then you adjust the magnitude using a variable. So we have just the forward direction with the magnitude and the time.delta time. And so that's how that works. That's how you thrust, you rotate, you play your particles, you play your sound effect, you change the properties in the inspector using serialized field. Collision handler, load, level delay, other things. This is probably going to be like the other one, but simpler. We've got some private fields. We don't need to change these in the inspector. This is for use down below. There's also a debug key. So we have a little private helper thing, respond to debug keys. So this was coded during the development and bugging process. Remove and prod, of course. On collision, enter. So this is where we use tags. So because the rocket, our player, has the collision handler, it is detecting what it runs into and checking those tags. So did it run into something friendly? We're just going to debug. We're going to put in the log, hey, this thing is friendly. If we've landed on the finish pad, we're going to start the success sequence. If we hit fuel, well, this is for later. We see we've left that open for it to be implemented later. And that's something we could do now. We could, okay, I want to pick up fuel. And then we'd go down below and add pick up fuel. Boom. And now that is there. And we'll have, of course, you need a return type for all your methods. Yep. And so that's how you would do that. Nice. But if it collides with something that isn't friendly or finish or fuel, well, you blew up. So these sequences, it just handles transition. So we're telling, hey, it's transitioning, and this is likely used by other things to, to stop collisions and stop sound effects and these sorts of things. Although that's played here, you can just step through at this point. Hopefully I've done a good job at helping you get back into a Unity project. This is how you kind of step through it. How long was this? This was 44 minutes. Wow. But hey, this is non-trivial, and it's so rewarding. So once you do the work to reorient your mind, what am I looking at? How do I find information that I need? Utilizing the API, utilizing AI tools. And so Let's play this. We're gonna hit play. I'm gonna make the game screen here on the left bigger. Ah, yeah, now I got that oscillating, but it's not really a threat. Ding. And then we're here. Ooh, it's dark, and judging by the light, this looks like it might have a weird collision aspect to it. Like all these shapes. Oh. Oh. Oh, you can see the light on the top, the front of the rocket. So, boom. And then it just goes back to level 0. You could have a menu, learn how to implement a menu system, add it to this. Add fuel, pick up an object, have a limited amount of fuel. If you run out, you're out. Make another scene, add some objects to it, add it to the build index so it actually is picked up when you hit play. And yeah, go from there, kind of thing. That's how you would do that. Use the docs, the documentation, use AI, and have fun. Yeah, check out gamedev TV, which is where I got this tutorial from. And check out my stuff down below in the description, maybe, if I get around to doing all that. Thanks for watching. Please let me know if this was helpful. And have a great rest of your day, your weekend, your month, your life. Enjoy.